We're going to look at one other type of reaction. It's not one of the main five that we see most commonly, but it is one that is definitely important in chemistry. We use this one frequently as you get into higher chemistry. If you do AP chemistry, you would be doing oxidation reduction reactions definitely more often. They're also called redox reactions for short. Oxidation is when an element is going to either completely lose or partially lose electrons, or if it gains oxygen. Now, if it loses electrons, that means that it is going to have a positive charge, and so when it increases its oxidation number is that plus or that minus that we put onto an element when it loses or gains. That's also oxidation. Reduction is when you completely or partially gain electrons. And so gaining electrons we normally think of are nonmetals. They have negative charges, so they have decreased their oxidation number and hence reduced. So here would be an example of an oxidation reduction, and you can't have one without the other. So you can't have oxidation without reduction and vice versa. So what's going to happen is we know that magnesium has 2 electrons that it wants to get rid of. Sulfur has 6 electrons total, so it wants to accept magnesium's 2 electrons. That gives magnesium a +2 charge. Now that +2 means that it lost electrons. It also means that magnesium went from no oxidation number, so virtually like sulfur and magnesium are kind of like at 0 right now, their oxidation, and a +2 means that they have an increase in their oxidation number. Sulfur, on the other hand, because it gained electrons, went from a 0 to a -2, so it has seen a decrease in its oxidation number. You can't have one without the other. You can't have one losing without something gaining. So oxidation reduction will always go together in pairs like that. So magnesium is the one that we would say is oxidized, because by definition oxidation is a loss of electrons. So magnesium is the element here that's been oxidized, where sulfur is the element that we would say has been reduced because of that gaining of electrons, the decreasing of its oxidation number. This is just a chart that kind of just gives you an idea of what things would be considered oxidation versus reduction. The main two that we're going to be looking at would be the loss of electrons versus the gaining of electrons, so ionic compounds. And we're also going to be looking at an increase or decrease in oxidation number. But there's some other ones in here as far as if we had a covalent bond. We've talked about polar and nonpolar covalent bonds and things sharing or not sharing equally. So there's information in here that would tell you which elements were oxidized or reduced if it was a covalent bond. We're going to mainly be sticking with the ionic and then with the oxidation number as well. So if you're given a problem, you need to be able to decide what element is being oxidized and what element is being reduced. So here's the equation that you're going to be given. Now I would recommend that you rewrite this as an ionic equation with our net, when we did the net ionic equations, and we can maybe cancel out spectator ions and so on. So if we rewrite this as an ionic equation, we can see the plus charges and the minus charges, which will help us decide if we've gained electrons or lost electrons. First of all, this NO3 minus 1, you have an NO3 minus 1 over here too. So you haven't gained or lost with NO3. It's a spectator. Nothing has happened to it. But you have silver with a plus, and then over here you have silver with nothing. So that is definitely, in this case, something that has gained electrons. And because of that, we would say if it's gained electrons, then it has been reduced when it gains electrons, because its oxidation number has went from a plus to a nothing. And then you have copper, which had no oxidation number, to having a higher oxidation number. That means it's lost electrons, so it's been oxidized. So copper lost 2 electrons, it's oxidized. We have silver gaining electrons, and so it has been reduced. And again, that reduced is the oxidation number has gone down. If you think about it like that, sometimes it's hard to think about gaining electrons and then you think it's been reduced. Well, the oxidation number has gone down. That's where that reduced is coming from. Let's do another practice problem. They're not going to walk through this one, so let's think about what element is being oxidized and what's being reduced. And again, it might be helpful to write out your plus and minus charges. Now here you have sodium, but there is no charge. It's not a compound. And you have sulfur, and again, not a compound. But when you have an ionic compound, you can break it apart into its charges. So we have sodium with a +1, and there's 2 of those, and you have sulfur with a -2 charge, just from where it's at on the periodic table. So if you take a look at this one, we have sodium went from no oxidation number to having a +1, and so because sodium has a +1 charge, it has an increase. Oh, how much of this do I run? Right, increasing its oxidation number. Okay, it also means that it has lost electrons, 2 keys that would make it oxidized. And we also have sulfur, which by default is going to have to be reduced, but let's make sure it works. We have a gaining of electrons. We also see a decrease in its oxidation number. So we would have a reduced on that one. Remember, you can't have one without the other. So if you have something being oxidized, that means something does have to be reduced. Last practice problem, and this one just has more elements in it than in the other one did, but again, you're going to want to write it out with the charges. So we have magnesium, we have copper with a +2, and we have nitrate, which is a -1, and on the other side we have magnesium with a +2, nitrate is still a -1, and we have copper. So if we take a look on both sides, you have the NO3 -1 on both sides, so it really isn't, it's not oxidized or reduced, it's staying the same. But we have magnesium, and magnesium is seeing, magnesium is seeing a loss of electrons, and with its oxidation number it went from 0 to a +2, so it's seeing an increase in its oxidation number. So an increase would tell you that you have oxidation, and copper is actually gaining electrons, and it is going from a +2 down to 0, so it is seeing a decrease in its oxidation number, and so this one would be reduced, and magnesium is being oxidized. So there's our oxidation reduction for that one.